Let's look at how to find the normal to a curve at a given point. Okay, so this is very, very similar to finding a tangent. The only difference is a normal is perpendicular to the tangent. So in the previous video we found this line which has the same gradient as the curve at the point where it touches it. Now, however, we're going to be finding the normal. So that is the line which is perpendicular to the tangent at that point. Okay, so let's have a look at how we can do that. So first things first, again, the normal is a straight line, so we need a point and a gradient. The point is the easiest one to find, so let's do that first. Y is equal to 4 squared minus 6 times the square root of 4. So that's going to give us 16 minus 12, which is 4. So our coordinate is 4, 4. Okay, let's have a look at how to find the gradient. So again, we need to put this in index form first if we're going to differentiate. X squared minus 6x to the half. Differentiating gives us 2x minus 3x to the minus half. Again, we want the gradient of this. This is going to give us the gradient of the curve, remember. X is 4, so we have 2 times 4 minus 3 times 4 to the minus half. 2 times 4 gives us 8. And then we've got negative powers, that's a reciprocal of 4 to the half, which is 2. So we've got 8 minus 3 halves. Let's just get that as a fraction. 13 halves. So we know that the gradient of our curve at this point is 13 over 2. But remember, that would be the gradient of the tangent at that point. We want the perpendicular tangent gradient. So negative reciprocal, remembering way back in coordinate geometry, minus 2 over 13 is our gradient. Okay, so y minus the y coordinate is equal to gradient. And then you can use either form, maybe you prefer this form, or if we've multiplied up by that denominator, this form. It really doesn't matter which form you use because your first step is always going to be remove the fraction. So either way you've arrived at it, you're going to get your next step as 13y minus 52 is equal to minus 2x plus 8. Gathering everything onto one side, we get 13y plus 2x minus 60 equals 0. And that will be the equation of our normal. So exactly the same steps as finding the tangent. Make sure you've got a coordinate, and then we need a gradient. So we differentiate to find our gradient. Substitute in the x coordinate. The extra step we have, however, is that we want the perpendicular gradient. So we use the negative reciprocal. Once we've got the negative reciprocal, we just use change in y over change in x is the gradient, as it's now a straight line, and simplify into the form we either requested or a nice sensible form.